Alright, let's talk a little bit today about relative motion. And relative motion deals with objects moving and different reference frames. So there's some, maybe there's some reference frame that's still, another reference frame that's still, but displaced from the first one, and then another reference frame maybe that's moving. And how do we relate these things? So let's start by diving into an example. Let's say there's you got a platform here, and there's some guy on the platform, and he is playing, I don't know, let's say we want to start from the bottom of the platform. So say he's playing hacky sack, and he kicks this little ball up from the platform, and the ball, which is being green, has some initial velocity, which I'm going to do red here, of v naught, and that's with respect to the platform he's on. Initial v with respect to platform. Okay, and then we can attach some some coordinate frame to the platform. So we can say right here 0, the ground of the platform is 0, and then y goes up from there. So that's the platform's reference frame. Now, and so in this reference frame we can just say initial y is 0, and the acceleration is going to be probably negative g. Okay, so that's all well and good. Now, what happens when we have some guy on the ground here? So there's the ground, and there's this guy on the ground, and he's looking up, and he can see the guy and his ball on the platform. Say it's got a glass floor or whatever, and we'll say the platform is a distance h above the ground. Now this guy's reference frame starts down here. He's got his own coordinate system, and he measures it up from the ground. Y equals 0 for him in blue down there, and y equals 0 for red right there. So now what does the guy in the blue see? Well, he sees an initial position of h for the ball. It starts h up from the ground, right? And then v naught for him equals the red v naught. So I'm going to draw that in red, and we're going to use a different system in a moment, so don't worry if you don't have a huge supply of colored pencils family, you're still fine. And then the acceleration there is a equals negative g. Alright, so the next thing next wrinkle we want to add, let's say, is what happens when this platform here is moving itself. So the platform has some velocity, it's going up, and this guy is kicking the ball up, standing on the platform, and this guy down here is watching him. How do we handle that? So I'm going to erase some things, but let's just go ahead and set up a new notation system. This is something that was suggested by John Coley in his very nice physics book, and it's used actually pretty frequently. So John Coley probably didn't invent it, but it's a very it's a very handy system, and it lets you, most importantly from our perspective, it lets you use one color. So the system is that for any variable you put two subscripts on. So the first subscript tells us what the variable is referring to. So we're going to say the object that we're talking about. In this case, probably the ball, but maybe also the platform, whatever. So the first subscript is the object we're talking about. Second is subscript is the reference frame we're operating in. What does that mean? Well, what it means is you have two subscripts on everything, on every object, and each one is going to refer to either, or two subscripts on every variable. Each one's going to refer to sort of what your frame of reference is, and then what you're looking at. So I'm going to label these things. Ground is going to be G, platform is going to be P, and then ball is going to be B. Okay, so what's the initial position of the ball, B, in the platform reference frame? So we've got that Y sub BP, and initially the ball is just on the ground there, right? And we define that as Y equals 0 for the platform frame, so that'll be 0. And I'm going to put a little 0 on there for initial, but You get the idea. In fact, I'm just going to take this out and do this. So YBP, it means Y of the ball in the platform frame, and then YPG is the position of the platform in the ground frame, and then YBG is the position of the ball in the ground frame. So I'm going to say at time t equals 0, Y of the ball in the platform frame is, well, it starts on the platform, right? So it's 0. We define 0 for the platform as being right on the platform level, and the ball starts there. So initially YBP equals 0. At t equals 0, Y for the platform in the ground frame, well, that's H. That's always H. Well, for now we're saying the platform is stationary. So YPG equals H. And then the nice thing about this subscript notation is that when you want to write an equation, adding different subscripts, or adding different y coordinates in this case, you can take the subscripts and they act as sort of a guide to this thing. So if you want to find, I'll tell you what, let me finish off. Y of the ball in the ground frame then, so the ball starts at the same height as the platform, right? So that's just H. I'm sorry, it should be equals H. There we go, equals H. Okay, that's supposed to be a P. There we go. So the nice thing is about this, you can just write an equation and use the subscripts as your guide. And the way it works is like this: Y of the ball in the ground frame equals Y. So this is where the ball is in the ground frame. And to find that, we can just take Y of the ball in the platform frame and then add on how high up the platform is. Does that sort of make sense? So Y of the ball in the ground frame is what you're trying to find. You take Y of the ball in the platform frame and add to that Y of the platform in the ground frame. And so when you do these subscripts like this, this works out very neatly because you have matching subscripts on the inside. So this P here matches up with this P here, and you can think of them as almost sort of canceling out if you want to smash these two Y's together, and then you would just be left with YBG, which is exactly what we have. So it's a tool if you always do your subscripts like this, so that the first subscript is the object you're looking at and the second subscript is the reference frame, then you can use that as a little tool to guide you in writing your equations. And it's enormously useful. The important thing to remember is it only works when you do addition, not when you do subtraction. Now, once you've got this, you can go ahead and do all the algebra tricks you want, right? That's what algebra is, taking one true statement and finding another true statement. So once you've got this statement set up, it's all good. But you do want to only add when you're initially setting these things up. So for example, if you tried, say, Y of the ball in the ground frame equals well, say you want to try like y of the ball in the ground frame plus Y of the platform in the ground frame equals Y of the ball in the platform frame. Does that work? Well, actually, no. You're taking Y of the ball in the ground frame and Y of the platform in the ball frame, or sorry, the platform in the ground frame, and then you're adding them to get Y of the ball in the platform frame. But you can look at your subscripts and say, well, BP, so I should be able to switch these around in some way, order them in some way that puts a B on the beginning and a P on the end, but you see I can't do that. So I know then that this thing here is wrong. So I think I really do recommend this strongly because it's a way to make sure you get things set up properly. I'm going to continue with this in the next video.